Hi, my name is Yonette Scott, and I will be performing a tutorial on multiple regression. I am using SPSS version 18, but any other version, I believe from version 15 should be fine. Multiple regression is used to predict the values on a quantitative outcome variable using several other predictive variables. They can be quantitative or categorical. The data set I'm using is found on the internet. Clicking on it right now, it's SPSS Green Salkind bridge page, and you click on the link. You open it up, click on the Green Salkind folder, and you click on lesson 34, and you use lesson 34 data 1. Data 1. So the file is opened up. Um, I'm gonna be doing a multiple regression using one set of predictors. Okay, to begin, you start with clicking on Analyze. Once you've clicked on the Analyze on the toolbar at the top, you're going to go down to regression and over to linear. Once the linear regression tab is open, you're going to select injury and move it over to the dependent tab. And then we're going to use four other variables. We're predicting whether or not these women are prone to injury based on the strength of the other parts of their bodies. So the other parts that we're going to use, if we're going to actually try to select them all and put them in the independent tab. So we're going to use quads, gluts, abdomens, arms, and grip, and then we're going to move it all to the independent variable. Once you've done that, you're going to click on the statistic tab, and once you're in the statistic tab, you're going to notice that the estimates have also been already been selected and model fit. We're now going to select some other tabs in here. It's going to be the confidence intervals, descriptive, and part and partial correlations. Once you've done selecting those additional three tabs, you're going to click on continue and OK. And the multiple regression. Now the first set of data at the top is my syntax data, and this is just the written commands for what I just did. If you notice, it tells me the data that I used, what my dependent variable was, and its injury, and the independent variables, quads, gluts, abdomens, arms, and grip. Moving down, and it's going to tell me that I did a regression and that I obtained the from the data set from uh, Green Salkans and where I got it from. Um, in in this tab, you notice that there's a listing of the data that I used: injury, quads, gluts, the variables, abdomens, arms, and grip. And this is we're gonna move to the gonna up in a little while. The model summary here. In the model summary, the R is the multiple correlation coefficient, and the maximum value for this multiple correlation coefficient is 1. If you notice, the value that we've obtained is 0.426, and and the sum squares and the R squared is the value we obtained is 0.182, and this is an indication that there's, I believe, 18% percentage of variance of variance of the injury variable can be of the dependent variable can be predicted. The ANOVA tab, let's go back up first before we go to the ANOVA, to the correlations tab. And this correlation tab, it's It's not the combination correlation, it's the separate correlation of each independent variable correlated to the dependent variable injury. And if you look at it, you notice that they're negatively correlated. Quads to injury, gluts to, so they're all negatively correlated. Um, let's move on down to the coefficients tab. The coefficient tab is here, and in the coefficient tab, you have the significant. Well, we haven't looked at the ANOVA. Let's look at the ANOVA. A significant less than 0.05, and if it's less, that means it's significant, and that this model fits very well. It works. It's a good predictor of the dependent variable. The coefficient also is significance. If you look at it, is less than 0.05. They're all 0.33, 0.003, 0.4. The highest one being the abdominals, which is closer to 0.5. Um, and the fact that it's less than zero point 0.5, it means that it's significant, and that this is in combination. The variables are in combination. They're being correlated to the dependent variables. So you get a better picture or predictor of the outcome of the dependent variable that when grouped together, combined together, you get to tell whether or not these women will be prone to injury or will be injured based on the strengths of those other body parts. In order to predict whether the dependent variable um, will is possible or will probably occur, it was best that we have most of the variables in there. I guess the more they're together and working in combination, the better predictor it will be.